Hello there, welcome to Chemistry Chapter 4, Lecture 2. So in this lecture, you're going to need your note sheet. We're going to be at the bottom of page 2 on your notes to start out. You're going to need your book and turn to page 122. And you're also going to need, part of your homework is this balancing worksheet. Worksheet C.1, and I'm gonna work a problem on that for you so that to make sure you understand the assignment. Okay, so today we're talking about chemical reactions. Okay, so a chemical reaction is a chemical change, and a chemical equation. Okay, so here we have carbon plus oxygen makes CO2, carbon dioxide. So I've written it out on the whiteboard here. So the letter that's in parentheses means the phase of matter. So S is solid, G is gas, L would be liquid. All right, and one maybe you've never heard of before, AQ, that stands for aqueous. That means dissolved in water. And then you also have an arrow. An arrow means yields, okay? So you can think of yields as it makes or produces. You know, that might be, so that arrow means that carbon and oxygen, so this side are the reactants. And then the right side we call the products. All right, so solid carbon and gaseous oxygen will react to make, to yield, to form, that's the arrow, gaseous carbon dioxide. Okay, so you need to learn all this, what all that means. The left side reactants, the right side products. So a balanced, chemical equations have to be balanced. Otherwise, they don't follow the law of conservation of mass. All right, so balanced equations ensure conservation of mass. So a balanced chemical equation, the number of each type of atom on the left side of the equation must equal the number of each type of atom on the right. And you can only change the coefficients, okay? You can never change the subscripts. All right, so you can change the number out in front of the compound. So we could put a number out in front of carbon or oxygen. That just means there would be 2 oxygen molecules if we put a 2, or 2 carbon dioxide molecules if we put a 2. But we can never change these subscripts. Okay, that would change the identity of the compound, so that you can't change the 2 or the implied 1 here or the 2 there. You can't change a subscript, only the coefficients. Okay, so let's look at 4.6. So in 4.6 it says determine if the following equation is balanced. All right, we are on page 122 there. So let's write this out. We've got 2C2H6. And right now the phases of matter the phase doesn't really matter, plus 7O2. And that yields 4CO2 plus 6H2O. So we want to see, are these balanced? So what we want to do is underneath the arrow, I'm just going to list all the elements. So we have carbon, we have hydrogen, and we have oxygen. Those are the 3 elements involved in this chemical reaction. And I want to count up all the carbons on the left, all the carbons on the right, all the hydrogens on the left, count up the hydrogens on the right, and then count up all the oxygens on the left, count up all the oxygens on the right, and see if they are equal. They have to be equal, or the equation isn't balanced. So for carbon on the left, I have 2. What you do is you multiply the subscript by the number out front, the coefficient out front. So on the left, we have 2 times 2, which would be 4 carbons. On the right, we have 4 times, now that C there's no subscript. If there's no subscript, that means 1. So we'd have 1 times 4, which is 4. Okay, hydrogen. I've got a 2 out front times 6, so that's 12 on the left. And we have a 6 out front times 2 here for hydrogen, so that's also 12. So far we are balanced. Then oxygen on the left, we have a 7 times 2, which is 14. And on the right, I have 4 times 2, which is 8, plus I have oxygens and water, 6 times 1, right? That there's nothing there, so that implies it's a 1. So 6 times 1 is 6, and that is 14. So the answer for 4.6 is yes, it is balanced. Excuse me. There you go, 14. All right, let's look at 4.7 right underneath. So we've got 6NH4Cl. We're not given the phases here, but we don't need to know the phases in order to balance. Al2S3. And that yields AlCl3 plus 3H8S. Okay, let's list all the elements. I like to do it right underneath the arrow here. We have nitrogen, hydrogen, chlorine. We have aluminum, and then sulfur. And you don't want to list any element more than once. Okay, let's start with nitrogen. On this side, there's 6 times 1. There's just one nitrogen. 6 times 1 is 6 on the left. And on the right, we have 3 times 2, which is 6. So far, nitrogen's balanced. Hydrogen, we have 6 times 4, which is 24 on the left. And on the right, we have 3 times 8, also 24. So we're good to go for hydrogen. Chlorine, on the left, we have 6 times 1, which is 6. But on the right, we have 1. So if there's nothing in front of the compound, if there's nothing in front, that's an implied 1. So 1 times 3 is 3. We could actually stop here because we know that we are out of balance. So the answer already is no. Now I'm going to go ahead and do aluminum and sulfur. So aluminum, we have 1 times 2, which is 2. But on the right, we just have 1 times 1, only 1 in this aluminum chloride compound. So that's also not balanced. Sulfur, we have 3, 1 times 3 on the left. And on the right, 3 times 1, so also 3. But this equation is not balanced because both chlorine and aluminum are out of balance. And if any of these 5 elements were out of balance, then the equation is not balanced. All right, so as you get good at this, you probably will not have to write everything down. You'll be able to kind of balance it with your eyeballs to a degree. But we're just learning this now, so we'll go ahead and do it the long way to start. Okay, let's look at on your own 4.8. So flip over to page 125. And we'll read through this. So it says hydrogen and oxygen can react together violently to make water. Write a balanced chemical equation for this reaction. Okay, so one thing, we've got to write an equation. We know that the reactants are hydrogen and oxygen. But you have to remember that hydrogen and oxygen only exist in nature as a homonuclear diatomic. So hydrogen has to be H2. Oxygen has to be O2. Okay, it's part of the 7 that starts with 7 that you had to memorize in the last assignment, plus hydrogen also on that list. So we know that hydrogen plus oxygen react to make water. Okay, so is this balanced? Well, you can write them out to see if it's balanced, but I can just look at it and tell you that there's 2 oxygens on the left, 1 oxygen on the right, so I know this equation's not balanced. You want to write it out, go ahead, but you can also do that with your eyeballs. So in order to get it balanced, I can change the coefficients out front. Remember, I can't change the subscripts, but I can change the coefficients. Well, how about let's balance oxygen? If I put a 2 out in front of H2O, now I have 2 oxygens, 2 times 1, and we're balanced. But now hydrogen's out of balance. I have 4 hydrogens now. What coefficient could I put in front of H2 in order to make this equation balanced? All right, hopefully you made your guess, but it's a 2. So now I have 4 hydrogens, 2 oxygens, 2 times 1, 2 oxygens, and we are in balance. Now, you do have to have those coefficients in their simplest form. So if we ended up having 4, 2, 4, it would be balanced, but we would have broken the rule on having them in its simplest form. So I like to try to get it in its simplest form to start with so that I'm not having to reduce. All right, let's look at 4.9, which is just underneath. That one says solid calcium carbonate, CaCO3, is made when solid calcium reacts with gaseous oxygen and solid carbon. What is the balanced chemical equation for this reaction? Okay, looking through that, what is on the right side of the arrow? What is made? Well, the problem says that CaCO3. And it also tells us the phase. It says it's solid. Now, our reactants, what's on the left, we have solid calcium, so I'm going to put an S there, plus gaseous oxygen. Now, oxygen is not just O, is it? That's a homonuclear diatomic, so we have to put O2. All right, so let's take a look at this. Oh, I'm sorry, and we forgot, apologize, you might have to, we've also got carbon, we've got solid calcium and solid carbon. So I forgot the carbon there. And that makes CaCO3, which is solid. All right. So that is what the shells of crabs and other shellfish are made of, calcium carbonate. All right, so let's see if it's balanced. Well, carbon's balanced. There's 1 carbon, 1 carbon. Calcium's balanced. There's 1 calcium, 1 calcium. However, oxygen isn't balanced. We have 2 oxygens here and 3 oxygens here. So I'm going to give you a little trick on how to do this when you have 2 and 3, or if you had 3 and 2. Or you could also do it with 4 and 3. Anytime you have digits that aren't direct multipliers of each other. What you can do is there's a 3 here. We can put a 3 as the coefficient in front of oxygen. And we have a 2 here. We can put a 2 as the coefficient in front of calcium carbonates. That balances oxygen. On the left, we have 3 times 2, 6 oxygens. On the right, we have 2 times 3, 6 oxygens. And so that was kind of the tough one. Everything else is easy to balance. I have 2 calcium, so I can put a 2 right here. And I have 2 times 1 or 2 carbons. I can put a 2 right here. So I like to wait for the individual elements to balance those last, because they're really easy to balance. All right, and then it says to balance. So of chapter 4, this is the last on your own problem. We have C5H12 plus O2 gas. And that's going to make CO2 gas plus H2O. And that's also a gas. Okay, so with something like this, my suggestion would be let's leave the element that's kind of by itself, not part of a compound, so just oxygen, let's leave it last. You can always fix the one that's all by itself easily. So let's start, I'm just going to go left to right. Let's start with carbon. I have 5 carbons here. I have 1 carbon here. So let's put a 5 in front of CO2. And now I have 5 carbons, 5 carbons. I have 12 hydrogens here. I have 2 here. So let's put a 6 in front of H2O. Now I have 12 hydrogens, 12 hydrogens. So now carbon and hydrogen are balanced. I just need to fix oxygen. Well, for oxygen, I have 5 times 2. I have 10 on the right side plus 6 times 1, 6. I've got a total of 16 on the right. So what number should I put in front of O2 on the left to make it balanced? Well, what times 2 is 16? 8. So you do need to know your multiplication tables to make it easier, but you can use a calculator as well. So now I have 5 carbons on each side, 12 hydrogens on each side, and then I've got 16 oxygens on the left, and 10 plus 6, 16 oxygens on the right. Okay, so I want to alert you before we finish up this lecture. Part of your homework will be this keeping track of atoms worksheet. And I need to teach you how to count up the atoms in a polyatomic ion. So we haven't talked about that yet. So I'm going to do one of these for you. I'm going to do 2D. All right, so this is on the worksheet C.1. So 2D, we have 4 out front, and then we have magnesium, and then in parentheses, OH, 2. Now, the reason it's in parentheses, we think of OH, it's called hydroxide. It's a polyatomic ion. You'll learn all about them. You have to memorize a bunch of them in Chapter 9. But it's a single unit. It reacts in chemistry kind of as a single unit, so that hydroxide. So the question says, how many of each of these do we have? How many magnesiums? How many oxygens? How many hydrogens? Well, for magnesium, we have the 4 out front, and there's just 1 magnesium. So it's 4 times 1, which is 4. But when you have these polyatomic ions, you got to look at it a little bit different. So inside the parenthesis, there is 1 oxygen, but you have to multiply that by the 2 outside. This means there are, in this compound, there are 2 hydroxides, 2 OHs. So you have 1 oxygen times the 2 outside, 1 times 2, times the 4 out front. Right, so we have a total of 8 oxygens. And this, in this case, the same thing with hydrogen. We have 1 times 2 times 4. 1 hydrogen times 2 OHs times 4, which is 8. So let me just make up one. Let's say we had Al2SO4 3. So this isn't on the worksheet. I'm just giving you a freebie just to make sure you understand. And let's say there's a 3 out front. So this is a little fancier. The name of this compound is aluminum sulfate. Okay, you'll learn that in Chapter 9. But how many aluminums do we have? Well, I've got 2 here multiplied by 3 out front. So a total of 6 aluminums in this ion. All right, you can think of it as a compound ion. All right, sulfur. I have 1 in the SO4, 1 within the parentheses, times 3 outside the parentheses, because there's 3 SO4s in this compound, times the 3 out front. So that is 9. And then oxygen, I have 4 times the 3 outside times the 3 out front. So 12 times 3 is 36. So that's how you count it up when you have these parentheses or polyatomic ions. Now, I had a student, I remember years and years ago, who says, why is it O4? Why isn't it O2? Because of the poly. It's only O2 when you have oxygen by itself. You can have all sorts of iterations of oxygen, but if it's just by itself, then it's going to be O2. Okay, so don't let that O4 fool you. You can have something other than O2 because it's with sulfur here. It's not all by itself. Okay, let's talk about your homework assignment. So you're going to finish up the review questions. So review questions, page 131. You can do number 10. Practice problem on page 132. You can do 5 through 10. And then your C1 worksheet, keeping track of atoms. So you can do a lot of counting and just make sure you show your work on this. Don't just put yes or no. Show your work. Count them up. And don't forget there's some on the back as well. So you'll have to write out nitrogen, hydrogen, oxygen yourself on this. It's not on the back. It's not neatly written out with blanks for you. So you'll have to make those blanks yourself and then say yes or no. All right. So if this video helped you and you are so inclined to do so, you can buy me a coffee. The link, I'll have a link in the description box, or you can scan this QR code and give me a little donation for this video if it's helpful. I would appreciate that. And also I'm going to link to the vinyl of the day. This vinyl I like so much. It's one of my favorite albums of all time that I actually have it framed on my wall, so I didn't take it out of the frame. But the band is called Supertramp. And the name of the album is Breakfast in America. Absolutely a perfect album. I love every song on it. So feel free to listen to that while you're trying your homework, if you are so inclined. And I will talk to you next video.